So this is going to be object-oriented programming theory. Now there's videos on the programming side. I will be using C# for this, so it won't just be pure theory. So there's the playlist there, creating an object. So some of the C#, if I'm going through it too quickly, or you want a different explanation, there's some stuff here as well. The one we're doing now will appear where the arrow is there. Okay, right, so I'm going to be going through these notes essentially, and try and explain those to the best of my ability. Now, OOP is something you can use in your project. It's also something that can occur in paper 1. So it doesn't occur every year, so some years is way more OOP heavy than others. So the skeleton program that comes out in September, if it's OOP, then you're going to be doing more OOP otherwise, okay, because otherwise there's not a lot of it in the, well, there won't be probably any in the exam, I would have thought. Now, so key terms, a class. Now, objects and classes get a little bit confused, but a class is like a template, and objects belong to that class. Okay, so you student class, and then you have individual students who are objects of that class. Okay, instantiation. This is when an object is defined on a class. All right, so you instantiate an object. Encapsulation. Now, what this means is combining the data structure of the class and the procedures and functions to manipulate it. Now, basically what that means is that the class contains everything it needs. Okay, so the fields or the data and the methods or functions to manipulate that data. Inheritance, a class that shares its fields and methods from a parent class. We'll be talking about what are fields and methods. Methods, we already know what they are, but fields, basically variables. Polymorphism, an inherited method, can be coded differently. And again, this won't mean anything at the moment. And then we've got aggregation and composition. Now, apparently the AQA sort of definition of these differs from most other people, so we just have to go with the AQA one. A loosely based relationship based upon classes, so a car and a person. If a car is scrapped, the person lives on. But there is a relationship. A person can have many cars, but basically what he's saying is when the car gets scrapped, the person usually lives on. Composition, a strongly based relationship. So, for instance, the car and the engine. A car is composed of an engine, if you like, if you try and remember it that way. When the car is scrapped, the engine would also usually be scrapped. Okay, there's always many caveats with these things. Right, why do we use objects? Well, object-oriented programming has been around for quite a while now. So it's something that can models the real world close to the structured approach. And you might be thinking, well, what the hell is a structured approach? Well, the structured approach is basically that you have a problem, you break it down. So you have a big problem, then you break it down into sections, and then break that down into sections, break that down into sections, that down into sections, that down into sections, until you've got small enough parts there so we can code it. Okay, so that's the idea. We breaking down a problem into smaller parts. That's what the structured approach was. Now, the object-oriented approach is supposed to model real world, because the whole real world is made up of objects. We're often trying to model the real world in terms of business applications, real world applications, such as using shapes and things like that, and as we use the vectors and things like that. So we can reuse code that's already created easily, and importantly, without breaking existing programs. Now, if you do a Windows form application, you are using, when you put a text box on the form here, or a label, that is an object, okay, of the text box class. And all text boxes belong to that. So the next text box will have the same properties and methods to do with that. Now, to be honest, text boxes don't really have methods, but if I was to do a list box, which I probably should have done first, this would be a list box. Okay, now it'll have properties such as count, and it will also have methods dot add new, and you can also think about a list in terms of C# as well, which is a list is a class, and then it will have when you create one, you create an object of that class. Now, okay, let's have a look at a class first. So this is what's called a UML diagram. So a class is like the template that we talked about before. So we can have fields, name, title, and rate. Okay. And we have methods, sort of update rate, get name, get title, get rate, and things like that. Now this is written in a very sort of generic way there. Now the minus signs here indicate private, and I've got a video on the difference between public, private, and protected. And then we have these are public. Now traditionally these fields are private and the methods are public. Now often you need getters and setters to set values and to read values. Now C# uses something called properties, which is much better, but we'll have to show what these fields look like. Now, so what we have here, there's a class. Right, so a class employee. Now what I want to do really is open this up so I can copy the code. Otherwise you don't want to see me typing it. So let's open that up. Now, let's get that. Now first off, I'm going to nick that stuff in a minute. But there's my code. Now what I'm going to do is I'm going to create a new class. Now there is a code snippet. It's one of the most useless ones ever. Okay, and I'm going to call that employee. Okay, now I'm going to copy that code that was in here. Okay, so right, the code is copied in. Now, right, so these are fields. You would call those variables normally, all right, and that's fine, but in object-oriented terms, they're called fields. We have a method there called update rate. That's void. We have get rate, which returns rate. Now you might be thinking, well, it's private. Yeah, but it's anything defined in the class is viewable within the class. But because that's private, you can't access that outside. Right, and we've got title. So how do we create an employee, if you like? So what you're going to do then, you're going to say the name of the class, employee, capitalize it. I'm going to just call it employee 1 equals new employee. Okay, so that's familiar syntax. You know, whenever you create a list or an array, it's the same sort of thing. All right. Now, if I type employee dot, you can see that these things here are the methods. All right. So I've got a lowercase. I'm sure I've got a lowercase get title. How did that happen? That's irritating. Right, get title. That's better. So that's essentially the very basics of it. Now it doesn't do a great deal, but we will do something with that in a minute. Now, what we would like is a constructor method. Now, a constructor method is a method that you call when you instantiate an object. All right. Now, so notice when I did employee there, it's new employee in brackets. Now, what we're calling there is an actual constructor, but it doesn't actually exist yet. All right. So now the constructor method is a special method that has exactly the same name as the class. All right. So here's my one here. Now you can get it to do it, okay, automatically. So I'm going to get it to do that. Now if I just click inside my class here and click on there, click there then on the class name. Right, generate a constructor. There we go. Right, so we have employee. Now, often what you want it to do, because it would normally help you if I use properties, I need to send in the name. So I want string. Now, there's several ways around this. You can do underscore name. So you differentiate your parameter here from the actual field. So I'm going to do underscores, but you could do capitals. But traditionally, parameters are lowercase. So title and then underscore rate. Now, I forgot to give those a type, so that's string and double. Now, so what we do here is we say name equals underscore name, and we say title. Now these are these fields that are private. Remember, we can't see those, so underscore title and rate. Okay. Right, so that's basically the same as what I've done in the notes. Now, what you'll see is now this is now erroring out because it's saying, oh, I'm expecting stuff in the brackets there. All right. So the first thing I want is the name. Now, I'm not going to bother putting using variables here. So let's use someone's name. So Zoe. So that'll do for that one. What's the next one? It's the title, doctor, and then the pay rate, which is a double, so 23.67. Now, make sure I've got the bracket there, which has disappeared, and now that's fine. Now, remember, when I do employee one dot, you can't see those fields. All right, you can only access them within that class. So now I've created a new employee, and then I can now do console write line employee one dot get title, and remember to do a console dot read line, and then run it. So 0. Now that should have happened. So let's have a look to see why. Get rate, return rate. That's right. Right, let's try it again. Because I'm running the wrong exercise. Idiot. Oop. That's the danger of doing it that way. Right, doctor, yes. Get title. Actually, I said get title and I meant, you get the idea. Anyway, it's worked. Okay, I could have done get rate as well. Okay, so what we've done there then is we can update the rate as well, and so forth by providing a percentage in. So let's change that to get rate, and then doing employee one, we'll call the method dot update rate, and we're expecting a double, so let's do 10.0. And then if we call get rate again, oh no, stop. Okay, and then run it again, we should notice that the rate has gone up by 10%. Okay, now, okay, so that's the raw basics to start with. Now the next thing is inheritance. Now this is what's called a kind of relationship. Is where you can have what's called a base class, and you can inherit from that with your derived classes. So a customer is a person, and you notice the arrows point up. Follow the arrows up. It kind of makes sense that way. So the idea of that is that you can have a class, person, and customer inherits everything from person and can add its own stuff. So it can use the methods and the fields that, well, they're private, but possibly private, but it can certainly use the methods that can access those fields in person. So how do we do that? Right, we can create a person class. So let's create a person class this time. Now, what you can do as well, when you have a class and you've got, let me make the text a bit smaller. Right, so when you have a class, you can make it its own class file if you want to. Now, so I can move to employee.cs and it takes it out of there. So it's all nice and clean, but now we've got employee CS there. All right, so that's a nice little feature, isn't it? Right, so let's do this one here. So the first one we're going to do class person. Okay, so I'm going to, I would do if I can get a copy. Right, so that's my class person. So I've got 3 private fields: name, sex, date of birth. I've got create, remove, validate, and so forth. All right. Now I'm not going to do all of these. I'll just do person. Now I'll show you the code. So I'm going to create a customer. Sorry, did I say person? Yeah. So I'm just going to do customer. So let's do another class. This one's called person, and then you do colon. Sorry, not person. This is employee, isn't it? And colon person. Now, if I just left it like that, when I create an employee, no, it's customer. I've already got an employee, haven't I? So it's customer, that's right. Right. So when I create a customer, all right. So let's just create a customer. Customer 1 equals new customer. I can now do customer 1 dot. Now I've got create, remove, validate. So remove dot remove. They're all there. All right. So I can access. Notice nothing's actually in customer, but I've inherited all of these methods, and these methods can access those fields there. So the nice thing about that is, let's say I've got this all working, person, and then I want to go, well, actually, there's a special type of person called a customer. I know all the code's working in customer, in person, then I don't want to mess with that. So I can just create my own stuff in here, and then, but I won't mess with what's in there. So I can add my new stuff specific to customer here. But that's not going to break anything that's already written in this one here. Okay, so that's your inheritance. Okay, now I'm not going to create an employee as well, but you get the idea. Right. Now, what's polymorphism? Well, polymorphism is like an extension of inheritance. So when a subclass has a method with the same name but its parent class, but it's coded differently. So in order to do that, we might as well use this example here. You can say, right, okay, let's create a new class in here, saying not class, method public void hello method. Okay. So, now in here I'm just going to write console write line hello from, now where am I? Person. Okay, so let's try that. So I can do that even though it's defined in there. I can say customer one dot hello method. Sorry, I need to put in a console write line. So console write line customer one dot hello method. Okay. Actually, let's change that so it returns a string. So we'll make that string. Shouldn't really, in your classes, you should try and make them as sort of agnostic as possible from whichever user interface you're doing. So let's just return that. And there we go. Right. So, okay. Right, let's just get rid of that so we can concentrate on the task in hand. Right, so let's just run that then, and it should just say hello from person. Is that the right one? Yes, it is. Now, if I wanted to do the same thing in here, it won't let me. So if I then did public string hello method and then I'm going to do const. Now it's right, so it's not letting me there. All right, let's just do return hello from customer. Okay, so now it's got the return, so it can't complain about that. All right, but so it's not letting me do that basically because I've already got one, so it doesn't know which one to call. All right, so what you have to do is the base class or the parent class must give permission for other children to use the same method name but coded differently. So to do that we use virtual here in C# at any rate, and then in here we're going to go public overrides or override, and then that should get rid of the error message. So when I run this now, customer one, new customer, and then it's going to write hello method. It should say hello from customer. All right, so that is our overriding. There's a different example there in the notes, but it's basically the same. So the keyword is virtual override. So there's the method create. I'm coding it differently in the customer class as opposed to the person class. Now the last bit is this composition and aggregation. So what we're saying is here is that we've got some relationships between engine and car. Now these numbers here represent so one engine will belong to one car, and then we've got a car may have 0 or many people. Sorry, no, that's wrong. So that's the wrong way around. So we're saying is a one person can have 0 or many cars. Okay, which is true. You may have none, you may have one, you may have many. All right. So now notice that this diamond here is coloured in, and this one here is black. Now, so what's going on there is this is the composition there. So the dark one is the composition, or the filled in one, and this one here is the aggregation. Okay, so that's the essential difference. Now in terms of code, what does that look like? So what we've got here is inside the car class here, we're defining an engine as a new engine. So that's created inside the car here. Whereas the person, we're saying public person, that one already exists. So that's the association. Okay. So hopefully that takes you through the notes there. No, I've just done that in Word, haven't I? Never mind. Doesn't matter. Now, now going back to OneNote, so you've got a couple of things to do. One is this OOP exercise in CS. So that takes you through a different thing with object-oriented programming. Now, what I will say is, in the classes, do not do any output or input. All right, just return stuff. The main can do the console write lines. Now, the idea would be that, you know, all of these is agnostic in terms of, I've said that word again now, in terms of the user interface, because it could be a Windows form app, it could be a web app, it could be a console app. Okay, the classes don't really want to know about that. They just want to return stuff or get stuff. All right, so this thing takes you through. Now, this was taken off a web page that was, it's a good web page that was using Java, so I converted it into C#. I certainly didn't write this because it's definitely an American. It says "you betcha" at some point. So that would be the one to do and have a go at that. So obviously you've got the video to this to watch, then have a go at that, and you've got these extra videos here as well. Okay, I've gone on long enough. Goodbye.